And the same has happened in Germany. Ancillary service markets collapsed. UK, ancillary service markets collapsed. So don't go chasing front of meter revenue stacks. It's a dumb idea.
They have better energy yield in indoor conditions because the spectrum indoor from the artificial light, like here, is different. Is not in infrared spectrum, but more invisible because all the lighting is focused only for visible light. And this is where perovskites perform much better than silicon.
Big projects, hundreds of megawatts or even gigawatts, tend to make headlines. But it's the many hundreds and thousands of distributed solar and storage systems that sets our industries apart, and the commercial and industrial segment is really a crucial one. Hello and welcome to another episode of the Smartery podcast. I'm your host, Jonathan Gifford. We're taking a closer look at C&I solar and battery energy storage systems on the pod today, and in particular in the UK and Germany, where PV plus BESS is making a very strong business case, particularly as the current energy crisis continues to drag on. But before that, we'll dig deep on solar technology itself with a pioneering and influential researcher. Marko Topič from the University of Ljubljana in Slovenia has developed a global reputation for the measurement, characterization and testing of solar cells, and we caught up with him on his home turf to get an update on perovskite solar cells and broader durability trends. Stick around to hear from Professor Topič a little later. Today's episode of the Smartery podcast is brought to you by Tag Mobi. Downtime is costing you more than you think. Tag Mobi, powered by Mobi Mentor AI, turns IoT signals into instant work orders, monitoring turbines, solar and BESS in real time, predict failures, optimize performance, and prevent outages. Tag Mobi, engineered for renewable energy across every site. If you're listening to or watching the Smartery pod for the first time, please do subscribe and follow. And if you're a regular, take time to leave a rating or review. And you can get in touch with us anytime at podcast@thesmartery.com. Well, the weeks roll by and energy supply chains remain very much disrupted. And that leaves many businesses, many commercial enterprises looking for answers when it comes to energy supply, which increasingly means solar and energy storage. Orkestra Energy is an energy intelligence platform, particularly in the modeling and the feasibility of battery and energy storage systems. And James Allston is the co-founder and co-CEO, and he joins me today. Thanks for joining the Smartery podcast.
Thanks very much, Jonathan. Great to be on the pod.
Well, James, tell me about this demand side. What are you seeing? I know that UK was one of your first market entries here in Europe. Are you seeing kind of some pickup in demand for the modeling, for the feasibility studies that are being done on your platform?
Definitely, but perhaps not for the reasons that you might expect, which is that, we suddenly got the Iran war happening and everyone's starting to think about energy security. That hasn't quite hit yet. I think what we're seeing in the UK, at least, is, from the Ukraine war, prices have not recovered, right? They're 71% higher than prior to, from compared to 2021 levels. And we're still seeing the massive influx of and interest in solar. And then these additional shocks that are hitting the system are only starting to kind of just started filtering through now. Many businesses aren't fully exposed to wholesale prices. They're going to lock in energy cost contracts. So if prices keep going up with this crisis, as customers are rolling off their existing contracts and starting to move on to much higher prices, we'll see demand for solar and batteries inevitably pick up as well. I'd also add one more thing, which is that TUANOS prices, so the transmission component of in the UK, just jumped 60% in the start of the month from last year's prices, and we're going to see, particularly for customers in the HV connections, so high voltage connections, a huge interest in reducing those prices and potentially reducing the capacity that they have on the grid and dropping to lower bands. So yeah, I think these are all factors that are just kind of already building on, you know, what is generally a pretty hot market for solar and batteries.
Yeah, well, it can be, it's a multi-year process as well, right? Like people don't switch their energy supplier or invest in a long-lived asset like solar and energy storage just overnight. So this is the second kind of energy crisis that Europe's faced within 5 years. So they can be compounding factors then, I imagine.
Absolutely. Yeah, this is all compounding, you know. You got the tailwind of decarbonisation, you've got the tailwind of collapsing, technology prices that we've seen over the last decade, and particularly in the last couple of years, like we've seen battery prices come down staggering levels, even in the last probably even in the last like 12 to 18 months, you know, the sort of default numbers that we sort of throw out to customers were like £400 per kilowatt hour for a battery. It's now £200 per kilowatt hour for a battery, right? So we're just seeing all these factors all compounding on each other. I mean, and this, this transition is happening. There's no politics about this anymore, right? This is just all commercial, good business sense. Let's go.
Yeah, multiple drivers, and perhaps in the long term, that kind of makes the market more stable and more reliable when it's not so driven by policy.
Absolutely, and I think that's something that I suppose many solar installers across Europe are probably licking their wounds a bit. The industry talks about even, globally, we talk about it in Australia as well, the solar coaster. And the solar coaster, historically was driven by, governments, swinging left and right and up and down on policy. And then that resulted to, hit the market. So you might have had a big feed-in tariff and then suddenly it was ripped away and everyone's left high and dry. That is all starting to like fade away, right? It's these drivers are not drivers of policy anymore. It's drivers of economies, technology coming down, underlying prices for electricity from the grid supply going up, and the interest in decarbonisation and electrification. The further thing is now layering on top of all those drivers is the intense focus on energy security. We're living in a state now where we're not even sure if we have enough avgas in Europe for the next 2 months. I mean, this is like, in the in 2026, when we've just lived through decades of like the land of the plenty, as a kid from the 80s, we had no sense of like limitations of the system. And now we're starting to realize, hang on, there is a limitation of the system, and it could be something as Donald Trump going and deciding to pick a war with another country, that the whole system is then realized that it's actually pretty fragile, and we've got to start thinking about energy security and sustainability in every country across the world, and stop working on the basis that we have a globalized economy where you could just move oil from the Middle East to another country in happy days. Like this has got to be that we start to get our localized energy supplies, and those are going to come from what's readily available globally, which is renewable energy, right? The sun shines everywhere, the wind blows everywhere, So let's take advantage of these things as front and center of some of the energy security concerns that we have across the globe.
Yeah, I think energy security, that's the real genuine paradigm shift from my perspective, right? That we always used to think that renewables, because they are intermittent, are less secure, when in fact we've really been exposed to the vulnerabilities of the fossil fuel supply chain. And actually, for full disclosure, both James and I are originally from Australia, but now living in Europe, myself in Germany, and you're in the south of France. We can see a beautiful background, is that right?
I'm sitting next to Lake Annecy, which is in the sort of foothills, quote unquote, of the French Alps. That mountain with the snow I just showed you is higher than anything we have in Australia. So that's when I say foothills, it's all everything's relative. But yeah, I'm about 45 minutes south of Geneva, sitting in the Alps here. So yeah.
Well, Australia is a really exciting kind of energy transition marketplace, but so very much is Europe, particularly having been exposed to these two energy crises this decade already. And after the UK, I understand Orkestra's next step was then into Germany in terms of your European expansion. What are you seeing in terms of demand from Germany?
Germany is like, fundamentally different market to the UK. So UK has the highest electricity market, highest electricity prices on average in Europe, right? So it's driven by that, and that's its fundamental driver. Whereas Germany is different because it's been building so much solar, at every part of the value chain, right? Utility scale, C&I, and the residential level, that now they're starting to see, prices hollowing out in the middle of the day. Now, that's something as an Australian, this is a bit old news. you know, we were dealing with this 5 years ago, guys. You're starting to talk about it last year. This is something that we're already starting to build the solutions for. It's like why Orkestra even existed as a product, and why it existed 5 years ago, not compared to some of the sort of startups that you're seeing in Europe, which just popped up in the last year. So I think we have the natural advantage as an Australian, having seen a lot of the problems, and we come from a little microcosm of energy, where we've got readily available renewable energy, big skinny grid, and all the problems that you're going to see across Europe, we've seen it in Australia already. So that's something that we have a natural advantage for. But zeroing down on Germany and specifically, there's a couple of things that are kind of really driving that market. So one is negative prices in the middle of the day. So there's a lot of regulatory change that's happening in Germany. That means that if prices are negative in the electricity markets there, you don't get paid your feed-in tariff. And obviously, for batteries, that's the best news story ever, right? Because now instead of like the opportunity cost being the feed-in tariff, the opportunity cost is zero, because you wouldn't have got it if you. So as prices continue to go negative, that will further reinforce the battery opportunity. The other thing that's really driving the battery opportunity in Germany is network tariff structures. In the UK, they have these time of use usage rates, right? So you pay on a cents per kilowatt hour rate, and it's a different rate depending on the time of the day, and the peak rate is between 4 and 7. And then in Germany, they have a different structure, so they charge you on the demand you use. But one of the things that's really interesting for batteries is, over the last few years, Germany introduced this thing called atypische Netznutzung, which basically, translates to atypical peak demand windows, right? So it's if your demand falls within these kind of windows that are set by the distributor, with each Stadtwerke, which is the local distribution utility, sets these windows. And if you're able to manage your demand within these windows and manage that materially down, you can see a significant cost reduction on the network side of your bill. So that is obviously a huge driver for batteries, right? And we're seeing that across the commercial industrial space, where they're exposed to these tariffs as being something that is really driving that market. This is all different to Australia, and this is something that, like, I've probably talked with you a bit about the past, Jonathan. But like, a key thing to understand about batteries is they're kind of like a Swiss Army knife, right? They're capable of doing all these different things, but you need to know when to get which tool out, or which combinations of tools out, depending on the situation that you're in. And the battery value stack that you have in Australia versus the UK versus Germany, each one will be different. And the driving forces that underpin all this might be kind of common, right? Bill savings, energy security, blah, blah, blah. But how you build the value stack and how you make that battery get the return on investment, is actually going to change depending on where you are within a country, right? It might actually change how the value stack is built.
Okay, well, actually, here in Germany, and just a few weeks ago, we were at the Battery Business and Development Forum in Frankfurt, and we're bringing some interviews from that event to the Smartery podcast over the next few weeks. And one of the key takeaways was there's a huge amount of regulatory uncertainty at the moment in Germany when it comes to utility scale storage. When you compare that to the C&I space, what are you seeing? You were talking about these demand charges and how that's a big driver of batteries. Otherwise, are there impediments to C&I solar and batteries?
Ooh, good question. I would argue a lot less so. And the fundamental reason is you have an existing connection to the grid, right? And what you're trying to do is reduce the load that's connected to that grid in a way that's favorable to the network, right? As opposed to introducing a new asset to the grid, which you have to somehow connect that in, and the grid operator's got to basically accommodate for this massive bloody battery that you put on the grid, and all the infrastructure around that is, has to be robust enough to cope with that, right? And that's introducing something new as opposed to adding something to something that's existing and changing the load profile in such a way that you're like actually making it better for the network, right? That's really the goal here, right? And Germany does, I think, the best job of any country I've seen so far. It actually, with the network prices, providing that price signal to actually reduce, demand for a load at times where the grid is constrained, right? And they've done that
when it's most expensive to supply that energy, right?
Exactly. Yeah.
Yeah.
Best of any market. In terms of the regulatory impacts, look, I'm not really in the detail of all of this. What I tend to do is I tend to try and work on the basis of a lot of these, you're going to sail through a lot of the regulatory impacts if you just come back to like core fundamentals. If you focus on tariff savings as opposed to trying to participate in some, ancillary services market, or even, even the electricity markets, you're in a place where you have access to the full value stack of the electricity system behind the meter, and reducing that full value stack is going to be in your favor, right? And the cost difference of being behind the meter, i.e., the more expensive batteries that you're going to have to pay for behind the meter because they're smaller assets, is actually not materially significant enough to actually, really affect the economics here. And you're likely to lead to a much, much better economic outcome. My third point on this is we see this in customers, right? So we have a lot of customers that used to be utility scale and are now moving behind the meter. I would say there's probably as many as well that are behind the meter moving into the utility scale. Is a blurring of it. But I think there's a recognition that behind the meter is just as valuable as the front of meter assets, if not more valuable in the right circumstances.
Interesting. And serving consumers directly. And we do know that ancillary services markets can be exhausted relatively quickly. So if you just focused on kind of customer demands, it's perhaps a more long-lived business model.
Exactly. And you've seen this globally, right? Frequency markets in Australia collapsed. There's no value in them left, right? I mean, except for like at the margins, right? And the same has happened in Germany. Ancillary service markets collapsed. UK, ancillary service markets collapsed. So don't go chasing front of meter revenue stacks. It's a dumb idea. Like, treat the front of meter value stacks as cream. If for whatever reason suddenly these markets all flash up and they're creating lots of revenue for everyone again, great. But bake that in as part of the cake. Just put that as cream on the cake. And if it comes, then awesome. You're in a well position to take advantage of that. But if you go in thinking that that's where you're going to make all your money, you're in for a bit of a rude shock, frankly.
All right. Well, a lot of motorists have been getting a rude shock lately, and that's also commercial customers, right, who operate large commercial fleets. What about EV integration then? Do you see a potential for C&I customers to integrate solar, integrate battery storage, and also electrify their fleets and then bring down their energy costs in that way?
Oh, God, absolutely. Yeah. I mean, I saw a statistic on The Guardian yesterday where, like, EV car sales are up 51% month on month, right? Like, it's just an explosion of interest, right? And the longer this crisis goes on, the more people will go and invest in it, right? And it's one of those things that, like, again, the train has left the station. It's the same as solar, same with batteries. The train has left the station. It's just a question of how quickly we get to, full penetration of, electric vehicles. And how does that translate into like the commercial opportunity? It's slower, right? And these people got own fleets already, and it's kind of like electricity prices. The people will lock in at a certain level, and at some point in time there'll be a moment in the future where they have to rotate that truck, or they having to recontract for electricity prices, and then they'll get this. They'll be like, oh, okay. Should we really buy diesel again, or is this the moment that we start thinking about electrifying our fleet? So this will act as kind of that another tailwind to the market into the EV space. And I think you'll see the consumer market respond faster, which we have, and then you'll see the commercial market then respond again. But yeah, the longer this crisis wears on, the more likely it is that you're going to see a staggering shift towards electrification. And it's something that as you know, us as a business, you know, we've been looking into as well. We actually raised nearly $3 million of Australian government money to actually build EV charging feasibility modeling into the Orkestra software. And that's going to be out into the world by August, right? So it's something that we're now responding to this change as well. And we're bringing forward, you know, some of the features that we're planning to do, acknowledging the fact that many businesses are going to start to look at electrification and are going to want to assess the feasibility of like, okay, well, now we're going to electrify the fleet. What is the best way to supply that? You know, it's going to be some combination of solar and batteries and electric vehicles, because it, you know, kind of back to the point of that we're talking about before around utility scale. One of the biggest challenges that we have with EVs is it is a new, you know, it is a new load to the grid, right? So you're going to have to install these things in such a way that the grid can cope with it. And you're probably going to want to invest in solar and batteries to kind of buffer your connection. And in many cases, you may not even be able to increase your connection at all. You know, somewhere like the Netherlands, this is a significant issue for them for just existing loads, let alone EVs, where you might have a, you know, industrial site and you're trying to put a new, you know, arm on your manufacturing line on your manufacturing site, and you can't get the connection for it. So what do you have to do? You have to go and build solar and battery system to kind of buffer the connection that you've got to the grid. And we're going to see the exact same use cases play out across Europe, for sure.
And this commercial fleet opportunity is a really big one when it comes to the market itself, which makes it quite exciting. All right, James Allston, the co-CEO and co-founder of Orkestra Energy, thanks very much for joining the Smarter E podcast.
Thanks very much, Jonathan. Great to be on the pod.
It's one of the most exciting areas of photovoltaic research and also the industry, perovskite solar cells and modules. And in terms of performance, some really encouraging results have been achieved, up over 30% conversion efficiency in tandem devices. But there are many challenges until perovskite solar cells become commercial. And one of those is in the testing, the durability, and also the characterization of perovskite devices. One of the world centers of developing techniques and technology for the characterization of photovoltaic devices, including perovskite solar cells, is here in Ljubljana, Slovenia. And Professor Marko Topič has established the solar group here, and he joins the Smarter E podcast today. Thank you very much for joining.
Thank you, Jonathan.
Well, I mentioned perovskite characterization, which is where you have particular expertise. Just can you give us an update? Where are we at in terms of perovskite technology development, in particular when it comes to durability?
Well, definitely it's a continuous progress, and they are the first PV systems put in operation, and we are eager to see how they will perform in outdoor, in real conditions, in field. But definitely it's a long journey to get to the expected and to be certified stability, which of course takes into account all the aspects of temperature variations, irradiance variations, humidity ingress or egress, and all these aspects need to be studied first in the labs. And of course, from starting with small cells, unencapsulated, so bare cells, but we know that they don't last long because humidity in the air already is aggressive to the perovskites. On the other hand, of course, we just developing the insulation layers to prevent water ingress, either of the lab cells so that we can test them, or then we encapsulate either the cells or the whole larger area mini modules or full size modules to be operated in outdoor conditions. And all this testing, of course, comes with the characterization, both on the material and device level. It comes along with the accelerated testing under the harsher conditions. And then, of course, most important is to make the root cause analysis for the degradation, where we should put special focus on and find a solution. Where are the problem, who is the troublemaker in the cell, and are they the interfaces, are they materials? And it turns out that there is a complexity of mechanisms so that we need to decompose and one by one solve the puzzle, and finally, of course, to reach the anticipated stability for any climate conditions where the PV modules will be put in operation.
So we have to first, you're doing the work, have to test and monitor and measure these devices accurately. And then kind of this root cause analysis to figure out what may have caused the degradation, the failures, and so on.
Yes.
And when you're looking at the results that are coming back from your testing, can you give us a high-level takeaway? Where are we at in terms of perovskite durability? Are we getting results that are encouraging?
Well, definitely. We started with testing for following the IEC standards for qualification tests. And there, one of the harshest one is damp heat test, which means both cells are exposed to the damp of water vapor and heat. It's 85% and 85 degrees Celsius for 1,000 hours. And this puzzle has been solved with perfect encapsulation and edge sealing. But then it turned out actually that during the exposure under light, the cells also degrade, even being perfect size. So we thought that we solved the problem. We solved the one problem, but then the other problems opened. So the more we do research and testing, the better we are in mastering the root causes, and so removing the root causes from the devices. And that's why there is a sunshine at the end of the tunnel, if I may say so. At the beginning, perovskite cells lasted for 1, 2, 5, 10 hours. And now we are speaking about 1,000, 10,000 hours operation time, which is quite a big difference in order of magnitudes difference, right?
And where would we have to get for, in terms of durability, for perovskites to be commercially ready?
I would say, of course, we need to compete with silicon photovoltaics, and they have proven lifetime of 30 years and warranty 25 or even 30 years, so that their power will not go below 80%, so they will be within 20% margin. We call it time T80 as 80% when the cells degrade to 80% of initial performance. And this is the, let's say, figure of merit for the research, also in the papers, in publications, and so on. But depends at what level you and how you degrade the cells. It turns out that, of course, it is the irradiance variation. Even the day and night cycling actually causes problems if not mastered on the proper way. Just recently we have identified for formadium cesium perovskite solar cells, so a specific solar cell where absorber is formadium cesium perovskite, that bromium, for instance, migrates and changes the crystal structure. So ions move around the absorber. And we are developing new techniques how to detect these mobile ions, when do they start to move, how do they move, which is even more interesting, that they go back. So it's a reverse process. not all the degradation processes are irreversible, going only in the one direction, but actually there is a lot of processes that actually are reversible. And that's, even we proved it in really an excellent paper on seasonality. Actually, both colder weather in winter and lower irradiance or irradiation as energy from sun affect that the cells degrade, but when the spring comes out, higher temperatures, more irradiance, the cells recover. So it's intermix of and complexity that we need to solve. It's a challenge, nice challenge.
Well, I know, particularly complex one, right? There's a lot of new kind of factors, new to PV factors at play. There's also kind of day-night effects as well. Yes. So in the winter, I know the HZB, the Helmholtz-Zentrum Berlin, yes, has an outdoor test facility, and they were reporting on the effects of kind of winter to summer, similar as you were saying. But these effects, the one that you were talking about in particular, that's a kind of, I've sometimes read about the healing, self-healing properties of perovskite devices. So that degradation may be picked up, but then under certain circumstances, that could reverse itself and they recover somewhat.
Yeah, that's the puzzle we need to solve. We call it metastability, because it is not, the cells are actually on a long run, we could say, for reversible mechanisms, they are metastable, so they degrade, but then they come up. And we need to learn why they degrade and why they come back. So it's finally, a perfect tool would be to have all the 3D picture on atomistic scale to see where the structure changes, what the interface is going on. But of course, those characterization tools do not exist. So we need to invent new approaches implicitly to understand what's going on. On the other hand, of course, we can go also to the, let's say, high energy microscopy, like in Berlin, you mentioned. And by the way, the paper I mentioned was actually a collaboration between Berlin and Ljubljana. It's challenging times, but good science. That's what we like.
Absolutely. And PV photovoltaics is underpinned by science, right? That's why we've got to this place where we are with crystalline silicon, that it's a reliable, bankable technology. And you need to understand these degradation effects for kind of professionals in the industry, because they need to build a project, they need to get financing, convince a bank, convince insurers that this is how the device will perform over time. And another part of that, and you mentioned metastability and characterization, you also need to, as the module rolls off the production line, be able to flash it and say, this is how many watt peak it will produce. I also understand with perovskite, that's also not straightforward in that they do exhibit these metastability effects. Is that right?
Yeah, but this can be incorporated because the nameplate power is the actual power within a class, so within a range. And you have to take into metastability into the account so for the course of producer that they need to declare a lower nameplate power, which is under standard test conditions. But coming back to silicon, actually also silicon solar cells and modules behave with metastabilities. Just recently, I was actually 2 weeks ago at the PV reliability workshop in Denver. And actually we discussed the UV-induced degradation for TOPCon solar cells. And this is going to be a highlight in the European Photovoltaic Conference in September. I'm among the topic organizers, and we will have dedicated sessions just for this. And it is actually research opens the new mechanisms, metastabilities or whatever, which under a lot of experimental work. And of course, we need to find the solutions for that. And we just in Denver, Professor Trubke, he mentioned there is a new kid on the block, new ID, new degradation mechanism causing metastabilities. to be solved.
In TopCon technology.
Yes.
Actually, we had a little discussion about that on the Smartery podcast a few weeks ago with Steven Jureb from PI Berlin. So that's worth checking out. But in terms of this characterization of perovskites, going back to perovskites, how close are we to having characterization equipment, which I believe has to be LED based, not the classic xenon testing?
Yes.
To having both the equipment and also processes that you can reliably characterize cells and modules running off production lines?
Yeah, we developed a special tool dedicated for the tandem devices, so perovskite silicon or perovskite, for to study how the tandem solar cells behave in terms of degradation or stability or metastability with using two LEDs, one for the top cell, which is blue light, and one for the bottom cell, which is infrared LED array, actually, because we can have also larger areas or mini modules to be tested. At the same time, of course, once the cell is perfectly encapsulated or sealed, you cannot dig in, right? But there are techniques which are remote techniques, and there are photoluminescence, electroluminescence, that then we combine. So during the long-term stability testing, we switch the same test field or the same device to PL or EL characterization, and then we have the qualitative as well as then quantitative analysis of what's going on. And it's in terms of inhomogeneities per area, what happens across the area, but at the same time, of course, based on the spectroscopy measurements, PL photoluminescence, can be also spectral spectroscopy, photoluminescence spectroscopy, so that we know what wavelengths are, and then based on that, we can then understand where the problems arise from.
Okay, and taking a step back from the detail then, there's a lot of activity in perovskite. There's equipment suppliers, there's research institutes like your own, there's scientists all over the world, and of course some startups trying to commercialize this technology. How confident are you by the progress that's being made that we are on the path to commercialization? I know it's the kind of $1 million question, and not always what researchers are seeing so closely, but you do see the fundamental research, and that underpins everything.
The progress is immense, I would say, and just recently, the first 1 megawatt PV system based on perovskites by Professor Hairen Tan in China has been put in operation for PV systems to generate real power. I mean, not just a few watts or a few kilowatts, but 1 megawatt is really a decent PV system to be tested outdoor. And obviously they passed all the tests that they planned for the qualification of the product. They have already made the modules for the market. On the other hand, there is also, I expect that the specialization or fine-tuning will go in different directions in terms of applications. Integrated photovoltaics is great. So to be integrated in anywhere, is it building integrated? Is it vehicle integrated? Is it infrastructure integrated? Not to mention floating and sound barrier integrated, and so on. But also, perovskites offer full color scheme of the PV modules, which means that the colors can be also fine-tuned to the needs of the customer. So they can be specific products for specific needs or demands. And that's the versatility that perovskites also offer.
I've also read about space applications as well. So that's the A0 spectrum. This is way out of my pay grade. This is what your expertise. But I have heard before that perovskite devices can be particularly well suited to this spectrum that's outside of Earth's atmosphere. And it's also an area where there's a lot of commercial interest, right? With these kind of data centers in the sky. Elon Musk has been out talking about
satellites for communications. Everything is there.
Exactly.
Perovskites do not like humidity. In space, there is no humidity.
There we go.
So, and perovskites are also resistant to the high energy irradiation, which means that they are more resistible than silicon.
So they can actually, and that is the self-healing that we were talking about before, that they may get damaged, but then heal when there's a dark cycle, or when the satellite moves where there's not direct sunlight, potentially.
Well, these movements are really fast. So
okay.
They are not 24.
Okay.
They are not on a 12 hours, but they are really fast.
Sure.
So it needs to be tested. I don't have an answer. But the responses are, I would say, fast changes do not affect that much. But by the way, our tools, we can test this also for the satellite changes of light and dark conditions of operation. It's a wide range of applications, including integrated photovoltaics for Internet of Things. And this is why is it so important, because also batteries don't have a, let's say, a CO2 footprint or ecological footprint as good as they should have. And reducing all the number of batteries needed to supply all the small gadgets to the notebooks and so on, that's also maybe a way to go for integrated photovoltaics.
And I was reading that's an area where your school has been, or your group has been doing research in terms of indoor applications and perovskite performance indoors. Why are perovskites well suited to indoors?
They have better energy yield in indoor conditions, because the spectrum indoor from the artificial light, like here, is different. Is not in infrared spectrum, but more invisible, because all the lighting is focused only for visible light. And this is where perovskites perform much better than silicon. Silicon is optimized for infrared light up to 1100 nanometers wavelength, while perovskites are up to 750 nanometers of wavelength, which means actually the visible part is covered ideally. And we can generate also with one single cell much higher voltage, and this helps also the electronics part to extract the energy out, that all the electronics already works at 1 volt. So you don't need any DC-DC converters for that, but these are also already details.
Well, but it's encouraging for anyone who's been frustrated at having to change the batteries in their Internet of Things devices, their fire alarms and sensors and these kind of things.
Yes, all the sensors, including some sensitive areas, not only explosion areas, but also because of the threat of the fire of the batteries, right? It's also really convenient to apply to.
It's encouraging to see this wealth of applications that perovskites can potentially be applied, and different pathways to market for these different startups that I was talking about. And in terms of these indoor sensors, you've established a research facility here in Ljubljana.
Yes, one of our PhD students, Dario Uršić, he made a PhD thesis, just finishing it, on a network of IoT sensors powered by perovskite solar cells, and this is ongoing already for more than 2 years, and just in perfect conditions, operating well, and of course being connected through Wi-Fi, so to be truly IoT as we want. Whatever sensors we will apply finally for the applications, but the concept has been proven.
Yeah, and we're going to see these sensors more and more as a part of our everyday lives and industry and everything. Now, Professor Topič, when we're here in Ljubljana and we're actually in the Dean's office. You are Dean also of the School of Electrical Engineering here in Ljubljana. Tell me a little bit about, I know this could be another whole half an hour conversation, but just give me an insight. How did you go about establishing the photovoltaic group here that really has developed quite a significant international reputation in the solar community?
I would say it's a long run. Definitely, it could be faster, but doing it step by step with a lot of effort and dedication. And of course, most important, to bring talents in the lab. And that was my privilege. I had best students in the class that wanted to study, to do research, to make PhD, and even they stayed. And my first PhD student is actually a full professor at our faculty. So I'm really proud, and I'm grateful to them that they contributed to. We really made a team spirit and made a success together. And that's what is, I believe, a wish of anyone who wants to work in academics, to have access to the big talents at the same time that they even stay in your group, and we grow together.
Yeah, and also making a contribution to photovoltaics, because it's been a remarkable technological story. And anyone listening to this podcast working in this field owes a debt to the scientists who have been making the fundamental improvements, the fundamental progress and breakthroughs, which all allow us to work in the modern solar industry.
Oh, thank you. Thank you for these nice words.
Well, thank you very much, Professor Marko Topič, here at the University of Ljubljana for the Smartery podcast. This podcast is a Climate Copy production. Graphic design by Nicole Schaefer, Ina Gossen, Wolfgang Weicht, and Peggy Hertetzille from Solar Promotion Lead Marketing and Coordination. And Matthew Denis is our video editor. Please follow, like, and subscribe on YouTube, Spotify, Apple Podcasts, or wherever you've found us. Get in touch with feedback, comments, or suggestions at podcast@thesmartery.com. And don't miss the Smartery Europe this year, from June 22 to 25. I hope to see you there. I'm Jonathan Gifford, and it's been great to have your company on the Smartery podcast.